Greetings everyone. This is Dheeraj Bijapur. Me and my friends Uday Kumar ND and Aniket Rajput today are going to present the embedded system internship project today, which we have done in Emertex. We are the students. We are currently studying in. We are currently in the final year students of the Anand Sagar College of Engineering EC department. Now, further, my friend Uday Kumar ND is going to start with the presentation.
Hello everyone, myself Uday Kumar. I'm a student of the Anand Sagar College of Engineering, EC department. I'm going to explain what we learned in Emertex internship and what we done our project also. Uh, Firstly, I'm going to what we learned in internship, the basics of C language. C language is a procedural language and it is used in many embedded systems. And procedural language means C is a procedural language focusing on sequence of instructions to solve problems, and it is also a structural language. It supports the structured program techniques, emphasizes the clear program flow through functions, loops, and conditionals. It means it has functions like loops and conditional statements, etc. And it is a middle level language. There are many types like low level languages, high level languages, but it is a combination of low and high level languages for manipulation of hardware system and software. C combines low-level features for direct hardware manipulation with high-level construct for program organization. And C is efficient and fast. Means like no, C is known for its efficiency and speed. C allows direct memory manipulation and access to hardware, making it suitable for system programming and developing performance and sensitivity. So basically, we use C program. It efficient in embedded systems. So and it is also fast. Where is C used? Uh, in our internship, we in embedded system we use C and C++ basically, and C is in our project we use C as a system software development and embedded software development and OS kernel development. OS means operating system like motherboards. We use C for basic and firmware and middleware and driver development and file system development. We use C programming for the following and many more. This is the basic structure of C programming. First, for every program we include header. It is same for every program, and in main also int main wide, and we start the this is programming statement and return statement. This is the body of the program. This is the basic structure of the C program and syntax. Coming to the topic, what is embedded system? Embedded system is basically combination of hardware and software. In this, embedded systems are specialized in computing systems designed to perform specific functions within larger system or product. Embedded system is combination of hardware and software. We like, for example, we are doing washing machine. In washing machine, we do programming for set of instructions for timing, timer, counter. It is all programming, and we use software like microcontroller, microprocessor. So it is basically combination of hardware and software. That is embedded system. These systems are tightly integrated into hardware. They control and typical operated within constraints of environment. Their particular situations only it will activate, like we manually or independently based on situations. It is works and control. Examples of embedded system: industrial robots. We it contains microprocessors and also programs. and GPS receivers, digital camera, DVD player, Wi-Fi routers, a set-top box, gamings, micro oven, photocopiers, and washing machine. We are doing that one. Categories of embedded system. In standalone is one of it is a standalone embedded system. In that, slave and independent embedded system. Slave means we give the instructions manually, like uh, in for example, in washing machine we set the timer and type of uh, mode, and other we give the instructions, then it will perform the action. In independent, it takes the action based on the situation, timing, like yeah, like if any change in environment, it senses and gives the accurate output. It takes the certain actions. And another category is real-time embedded system. In real time, it gives the uh, real-time output and takes the real-time input. A network means like mobile network. It is connected to the Wi-Fi or network-based embedded system. Uh, and mobile embedded system, like a mobile embedded system is like moving one place to another. It is also doing this particular work like automobiles. And hybrid embedded system means is combination of any of these two or more types of embedded system. And further topic will be explained by my friend Aniket.
So this is the block diagram of embedded system. Uh, Myself Aniket Rajput, and I am the part of this project of Emertex group, and we are making washing machine. And this is the block diagram for the whole system work for the whole working. The main part of this embedded system is CPU. CPU can be microprocessor, microcontroller, or in chip, and we can use various type of CPUs. And here we start in our embedded system from sensors. Sensors take data. Data can be analog or digital, and the data goes through ADAC. ADAC means analog to digital converter. It convert analog signal to digital signals, and then it gives signals to CPU. C and There we have one more converter called DAC. DAC means digital to analog converter. It it takes digital output from CPU and uh, convert into analog signal, and then it will pass that signal to actuators. We have various components along with the CPU. The first one is user interface. User interface can be as small as LCD, or we can make as a GUI, and it is used just to interact with the user. The second part is diagnostic port. It is used to check whether things are working fine or not, and it is diagnostic mode. It is used to check whether things are working fine or not. It just check the components are like working fine, or like the system is working fine or not. Then we have an auxiliary system. It contains power supply and cooling systems. It is like it is used to give power supply, and whenever the system get heats, it cool down the system. Then we have FPGA and ASIC. FPGA means field programmable gate array, and ASIC means and ASIC means application specific integrated circuit. We use these circuits in CPU to establish the embedded system. Then we have memory. Memory can be of two types, RAM or ROM. RAM can be also for two types, DRAM and SRAM. And memory also can be classified into various types like MUSP-ROM, EROM, EEPROM, EMP-ROM, and we are using EMP-ROM in this project. And the most important part is the software. Software is used to control the embedded system, and it is used to program the embedded system according to our need. And the further things we have is electromechanical backup and safety, and the external environment. It supports the whole embedded system to take into in this project. and after combining all these uh, functions and blocks, we can define our the main system. Requirement for embedded system. The first requirement for embedded system is low power consumption. It should consume low power, because if it consume high power, then embedded system get more heat, and it need a bigger cooling system. The second thing is efficient usage of memory. We should have an embedded system which can utilize the memory in an efficient way. If it doesn't happen, then the RAM will get filled and the process will get stopped. So we need to efficiently use the memory. Third thing is reliability. We can say the embedded system can perform at any time. The system should be reliable, and it should give continuous output. And the fourth thing is cost effectiveness. The embedded system should not cost much. Uh, uh, we should uh, we should take our embedded system according to the bare minimum one. And the last thing is efficient usage of processing. We should use the processing power according to our need, and it should be in an efficient manner. And whenever we are using embedded system, we should take a processor to use power efficiently, because if it is taking more power, then it it will get overheated, and we need a bigger cooling system. So we should use the power processing efficiently to perform more tasks. And here we comes for the application of embedded system. Embedded system are like everywhere, from car to phone to all our devices. Like in car, we have a cooling system, we have a air conditioner system. We are using embedded system there. We are using embedded system in robots as well, for the sensors, for the processing power. We are using embedded system in our Wi-Fi broadband to give a good network in our workplace and at our homes. We are using embedded system in our labs and in our equipments. We are using embedded system in medical equipment, and we are using embedded system in our daily life appliances, like a TV and a washing machine that we are making right now. And we are using embedded system in small things like mobile phone, ATM machine, and a camera. And we also use embedded system in like really large thing like rockets and airplanes. So these are the application of embedded system. Embedded systems are like at everywhere in this generation. The So here we comes for our problem statement. The problem statement of our project is to develop a washing machine interface and simulate it, which display and allow user to select different types of washing mode on pressing digital keypads according to the water level on the long presses. Whenever we start the washing machine, it should display functions running and remaining time left, and it also should stop when the lid is open, and it will alarm us from through a buzzer. And we use a few softwares to make this project. The first one is MPLab X IDE. It is an integrated development kit, a development environment to write the code for the C language and the embedded coding. And we are using version 5.50. And the second software we use is XC8 compiler. It is used to compile that code that we have written in the MPLab software. And the third part is picsimlab tool. It is used to simulate the software and simulate the whole project into a visual representation. So here we comes for our microchip or a microprocessor. We are using PIC16F877A. It is a PIC Genie OS board from Microchip. We are using this microcontroller for this project, and the bus width of this microcontroller is 8 bits, and we have total 40 pins, and there are 33 pins for the input and output pins, we as known as IO pins, and we have program memory of 14.3 kilobytes, and we have a CPU speed of 5 million instructions per second. It means it can take 5 million instruction every second, and we are having a RAM size of 368 bytes, and we are using the ROM of EEP ROM type of 256 bytes. So now the further part will be explained by my teammate Dheeraj.
Greetings. So I'm Dheeraj. So I'm going to start. I'm going to start with this. This is the architecture of the PIC16F877A microcontroller, which was just explained by my friend previously. So this architecture, as we can see, it gives us a brief idea regarding the board. In this architecture of this PIC16F877A microcontroller, we can see it has got LEDs, buzzers, digital keypad, display matrix keypad, CLCD, and it has also got ADCs. It has got LM35 temperature sensors, and it has got a EEPROM and GPIO. So this is all about the architecture of the board. Now the LED. LED are the most and the simple devices used. It emits the light as the energy dissipated here in this diode is in the form of lights. It is a it is just like any other diode, but in this case it emits the light, not like other diodes which emit energy. So it is used because of the many reasons, like it uses very less energy. It has got a longer life and smaller size, and it is faster. So it is almost used in everywhere in our day-to-day lives. It is used in home lightnings, remote controls, surveillance displays, and many more. It has got a wide range of use case. So then next, character liquid crystal display, also called also CLCD. So it is used to display, like it is kind of used as a monitor in our project. It displays whether the washing machine is on or off, it displays what are the modes present in the washing machine. To display all those, we are using this. uh, it can display both alphabets and numbers. It can work both on like 8-bit and 4-bit modes. In this, D0 to D7 are like data transfer lines. It has RS if 0 for instruction register and 1 for the data register. It has also got enable pin. So in this project, as told, we are using this for displaying the washing machine, whether it is on or off, and like that. Next, the tactile switches. The tactile switches are like the switches which work when they are pressed. When they are pressed, and when the contact is made, just for temporary. There are two types of tactile switches: level triggered and edge triggering. So these are used in olden days keypad mobile phones. Whenever we press some button, like when the connection is made, the circuit is full, and the circuit is made full, and the circuit is completed. The array of these tactile switches form the digital keypads. uh, Next, we have used the ISR, interrupt service routine, fan, and buzzer. Interrupt service routine, it tells the processor or controller when any interrupt occurs, like what to do and all. Here we have used the fan in our project to depict whether the washing machine is on or off, uh, and all. In the buzzer, whenever the washing machine is switched off, so at that time we use buzzer to indicate whether the washing is done, and we have to washing is done. So let me show like code for this. So this is the code which we have written in the. We have used MPLAB XIDE we have used the version 5.35. Here we have given like many modes in this, like daily, heavy, delicates, whites and all. So also we have given some water level selections like auto, low, medium and all. uh, this is the code which we have written for this. This is the switch statement which we have written to select the operation mode. This is the function which for the displaying of program washing program display. This is used to display the water level. This is used to check the door status, like whether it is closed or open. Like if it is open, the buzzer gets turned on and indicate and the process is stopped and indicates that the door is open and we need to close it. So that's all. So let us see this code in and simulate it in picsimlab. We have got built successfully, like it has got no errors. So we will open the picsimlab and see the simulation of it. First we will load the hex file which we have done. We have chosen the as we have told the pic board which we have told before. And so now we can see, like after loading the hex file, we have got press key 5 to power on the washing machine. Now we, like as I press the switch, it's going to turn on. We can see the washing machine is turning on, powering on. So as told, we have given many programs. Washing, there are around 11 programs. So as we have used this small display, like only 3 are visible. To select to move through all the modes, we can press switch. It has got many modes like stain wash, for woolens, for bed sheets, like for rinse plus dry, and like many more. Now let us select for this. Let us select heavy. For selecting, we need to do a long press. We should long press for around 4 to 5 seconds. As we can see now, the water level is getting shown. We can select the water level according to our needs. We have used the same, like as told before, for the proceeding further and selecting the options. We can click and move through the options. We will select medium in this. Yeah, okay, like if we press like now the all water level is selected and the mode is selected. Now we should press switch 5 to start and the switch 6 to stop. If we start, the timer starts and then the washing machine is turned on. As we can see, if we press 5, the timer has been started and we can see the fan is turned, like the fan depicts the washing machine, so it is turned on. We can see the timer going, timer is on. And to pause, we can press this uh, key and we can see that it is paused and the timer is also paused. So again resume, we can press this switch. We can see the timer is going on and the fan is on. We can also see the temperature of the washing machine here beside. we can see the timer is about to turn off. Yeah, as we can see, as the timer gets completed, we hear a buzzer to indicate that which indicates that the like all the washing process is done and we can remove the cloths which are washed. Again, it comes back to the main washing program menu, where we can again select these things, like where we can again select and do the same. Now we will select woolens. Again, as it shows, like auto, it has got the same things. So this is all regarding the simulation which we have done. So to conclude, uh, the washing machine simulation, it served as an effective tool for us for learning and applying concepts. We learned how to use the Pixim lab, Pixim lab, and the microchip compiler. It offered us a great hands-on experience, providing us a practical knowledge regarding the embedded systems, and we got a chance to explore in the field of automation and control systems. We thank the Emertex platform for providing us with this opportunity. So we would like to end our presentation here. Thank you very much.